Yes. Good morning, children. In the previous sessions, we have learned about the similar triangles and their applications. Today, now let us learn about the Pythagoras theorem, which is very, very important. What the statement of this theorem says: in any right angled triangle, square on the hypotenuse is equals to the sum of the squares on the other two sides. Let us draw one figure for this. Here, ABC is a triangle and BD is drawn perpendicular to hypotenuse. Here, angle ABC is equals to 90 degrees. Is right angle triangle. The term once again, in the triangle ABC, angle ABC is equals to 90 degrees. Now, what I have to prove is, in any right angled triangle, square on the hypotenuse is equals to the sum of the squares on the other two sides. So, which is the hypotenuse here? AC. Therefore, we have to prove that AC square is equals to AB square plus BC square. For that construction, yes, what is the construction here? Now, draw BD perpendicular to AC. So, this is the construction. Draw BD perpendicular to AC. Now, proof part. As you know that perpendicular drawn from the right angled vertex to the hypotenuse divides the triangle into two triangles which are similar to each other and to the given triangle. So, we have to compare the triangles here now. Yes, in the triangles, look at this now. One triangle, the triangles A, D, B and yes, A, B, C. You know that angle A is common. Angle D is equals to angle B is equals to 90 degrees. You have to compare now. Angle DAB is equals to angle BAC. Yes, reason is that common angle of both the triangles. Angle ADB is equals to angle ABC is equals to 90 degrees. So, by yes, AA criterion, these two triangles are similar. So, triangle ADB is similar to triangle ABC. When two triangles are similar, then their corresponding sides are set with a proportion. Those corresponding sides you can get here. Look at this now. AD by AB is equals to, yes, DB by BC, which is equals to AB by AC. Now, look at this, take these two ratios, AD by AB and AB by AC, and do the cross multiplication. AB into AB, AB square is equals to AD into AC, we have got it. This is the equation 1. We have compared. Here, triangle ABD with ABC. Let us compare here now BDC with ABC triangles. Now, in the triangles, look at this now. Yes, BDC, I am taking. Yes, you know very well that angle C is common. Here, in the triangle BDC, angle D is 90 degrees. In the triangle ABC, angle B, then A, you have to go take now. Look at this now. Angle D is equals to, angle B is equals to 90 degrees. Angle C is common now in these two triangles. When I am comparing this triangle with the ABC, angle C is common, I have to take. If I am taking this, here angle A is common. That's all the difference between these two. Now, compare now. Angle BDC is equals to angle ABC is equals to 90 degrees. One is from the data, the other from the construction, you know very well. Next, angle BCD, last letter, you can take is equals to angle ACB. Reason is that common angle of both the triangles ABC and BDC. Again, by AA criterion, these two triangles are similar. Therefore, triangle BDC is similar to triangle ABC. Again, when they are similar, corresponding sides are set to in the proportion. Therefore, BD by AB, yes, BD by AB is equals to CD or DC. CD by BC, which is equals to BC by AC. Look at this now. Now, here BC is there. Take these two and do the cross multiplication now. BC into BC. BC square is equals to, yes, CD into AC, equation 2. Look at the equation 1 we have got. AB square is equals to AD into AC and BC square equals to CD into AC. Add up these two equations. Equation 1 plus equation 2 implies or giving rise to, add the LHS term separately. Here AB square plus BC square is equals to LHS, we have got it. RHS terms are here AD into AC. So AD into AC plus in the equation 2 RHS term is CD into AC. Look at this now. AC we can take out common here now. If I take out AC as common, what you can get? AD plus CD. Look at from the figure. AD plus CD can be written as AC. This is equals to AC. We know we have what here now. From the figure, as I explained to you, AD plus CD is AC. Therefore, what you are getting here? AB square plus BC square is equals to AC square. That's what I have to prove. Look at this now. AC square equals to AB square plus B square. That means we have proved that in any right angle triangle, square on the hypotenuse is equals to the sum of the squares on the other two sides. Based on this, well, converse of Pythagoras theorem, what it is. But Pythagoras theorem means first only we say that in any right angle triangle. But whereas in the converse of Pythagoras theorem, at the end we have to prove that it is a right angle triangle. What is the statement of converse of Pythagoras theorem? Look at this now. Now, converse of Pythagoras theorem, I am going to explain very simple concept. Look at this now. Yes, converse of Pythagoras theorem. Right. What the statement? In a triangle, if a square of one side is equals to sum of the squares of other two sides, then the angle opposite to the first side is a right angle. Let us take one triangle here now. ABC is a triangle. Yes. Now, they have given what is a triangle. What they have given? Yes. Here, square on the one side is equals to sum of the squares on the other two sides. Now, you know that in the triangle ABC, they have given that AC square is equals to AB square plus BC square. But they have given that square on one side equals to sum of the squares on the other two sides. What have to prove? To prove that angle, yes, in the triangle ABC, we are going to prove that angle ABC is equals to 90 degrees. We are going to prove for the Pythagoras theorem. First only we have taken that as a right angle triangle. Construction. What is the construction here now? This is only important here now. Construction we have got now. Construct triangle PQR is right angle at Q. One, how we have to construct this triangle here now? See, we have constructed one right angle triangle in which angle Q is equals to 90 degrees now. So, what is the construction? In the construction, in the triangle PQR, angle PQR is equals to 90 degrees such that AB is equals to PQ and BC is equals to QR. Same pictorial notation shows that those sides are equal now. Now, proof part, we have to go for this now. What is the proof part here now? Yes, because from the construction we have taken this as a right angled triangle. So we can apply Pythagoras theorem. So in the triangle PQR, yes, in that triangle PQR, you know that from the construction we have taken as angle Q as 90 degrees right angle triangle. Therefore, by Pythagoras theorem, square on the hypotenuse. Which is the hypotenuse? PR is the hypotenuse. Therefore, PR square is equals to PQ square plus QR square. But from the construction, you know that AB is equals to PQ and BC is equals to QR. Therefore, you can write this as PR square is equals to PQ is nothing but AB. From the construction, AB square. QR is equals to BC. Therefore, BC square equation 1. Now, because of the construction, we have got these two steps here now. Construction, very important here, construction now. And from the data, we know that what they have given, AC square is equals to AB square plus BC square, equation 2. Let us compare these two equations. Here see, RHS terms are equal. When RHS terms are equal, their LHS terms must be equal. Therefore, PR square is equals to AC square. Therefore, PR equals to AC. When the powers are equal, bases must be equal. Therefore, we have what now? PR is equals to AC. Look at this now. We have got it now. Let us compare these two triangles. Now, in the triangles A, B, C and PQR, you know very well that AB is equals to PQ from the construction. Similarly, here BC is equals to QR. Just now we have proved that here AC is equals to PR by congruence. Triangle ABC is congruent to triangle PQR. When two triangles are said to be congruent to each other, they remaining all the corresponding angles are equal. Therefore, when angle PQR is equals to angle ABC. Now, to the PR, angle Q is the opposite angle. Corresponding side of PR is AC. To this side AC, angle B is the opposite angle. Therefore, angle B is equals to angle Q. Therefore, we say that angle ABC is equals to angle PQR is equals to 90 degrees. That means angle ABC is equals to 90 degrees. That means we have proved that if the square on one side equals to sum of the squares on the other two sides, angle opposite to the first side is a right angle. This is the converse of Pythagoras theorem. Based on this, let us work out some of the sums from the exercise here now. Exercise 2.5. Let us work out some of the sums here now. Yes, first sum here now. Sides of triangles are given. Determine which of them are right angles. In case of a right angle, write the length of the hypotenuse. First sum they have given now 7 centimeters, 24 centimeters and 25 centimeters. But prove that whether it is a right angle triangle or not. For that, converse of Pythagoras theorem. Square on the longest side. Among these three measurements, 25 is the longest side. Therefore, 25 square is equals to 625 square centimeters. Equation 1. Sum of the squares on the other two sides you can take now. 7 square plus 24 square. 7 square is 49. 24 square is 576, which is equals to 625 square centimeters. Equation 2. Look at this now. Square on the longest side equals to sum of the squares on the other two sides. Therefore, converse of Pythagoras verified. Then we say that from 1 and 2, we say that 25 square equals to 7 square plus 24 square. Converse of Pythagoras theorem verified. Therefore, the given triangle with these measurements is a right angle triangle. Where it is a right angle triangle, which is the hypotenuse? In a right angle triangle, longest side is the hypotenuse. This is the way you have to go further. Next sum they have given here, see, yes, 3, 8, 6 centimeters. 8 square is 64, longest side we can get now. 3 square is 9, 6 square is 36, 45. Sum of the squares on other two sides is not equals to the square on the other side. Therefore, converse of Pythagoras theorem is not verified. The given triangle is not a right angle triangle. If the converse of Pythagoras theorem is verified, then only it is a right angle triangle. This is the way you have to do the sums now. Right. Now, in the figure they have given now, let us draw one figure here now. Yes. What I have to prove? In the triangle BAD, angle BAD is 90 degrees, AC is perpendicular to BD. Show that first one, AB square is equals to BC into B. There are three parts. One part I'll explain. How do you compare now? See, in the triangles, which are the two triangles you have to take here now? A, B, D, and see, A, B, D, and yes, C, B, A. We can take now. C, B, A. C, B, A. When I am comparing C, B, A with ABD, angle B is common. So let us compare the angles here now. Angle BAD is equals to 90 degrees. Angle BCA is also equals to 90 degrees. Observe this now. This is 90 degrees, this is 90 degrees. Which is the common angle here now? For both the triangles, ABC and ABD, angle B is common. Therefore, angle ABD is equals to angle CBA. Reason is that common angle of both these triangles. By AA criterion, triangle ABD is similar to triangle CBA. When two triangles are similar, then their corresponding sides are said to be in the proportion. Write the proportionality, then you can get AB by CB is equals to BD by AB is equals to then AD by AC. What have to prove? See, AB square. AB we have, take these two, the other one leave it and do the cross multiplication. Therefore, you can get that AB square is equals to BC into BD. This is the way. Two more sums are there in this. Start doing yourself by taking the concept of similar triangles here now. Prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. Now it is a rhombus. They have given now ABCD is a rhombus. You know the properties of a rhombus? All the sides are equal. Diagonals bisect each other at right angles here now. That's all now. Yes. Now what to do here? Yes. In the figure, you know that ABCD is a rhombus. When it is a rhombus, you know that all the four sides are equal. AB is equals to BC is equals to CD is equals to DA, and in which AC and BD are the diagonals. Diagonals bisect each other. Therefore, we see that angle AOD is equals to 90 degrees. Look at this now. In the triangle AOB, let us apply the Pythagoras theorem. Yes, in the triangle, yes, you know very well that diagonals bisect each other. That means AO is equals to AC by 2, BO is equals to BD by 2. Yes, when they are bisecting each other, AO is half of AC, BO is half of BD. Let us apply the Pythagoras theorem in the triangle AOB. So, in the triangle AOB, angle AOB is equal to 90 degrees. By Pythagoras theorem, what do you write? AB square is equal to AO square plus OB square. You know very well that AO equals to AC by 2 we have done here. AC by 2 whole square. OB square means BD by 2 whole square. This is equals to AC square by 4. If I square this, BD by 2 whole square is nothing but BD square by 4. Take the LCM. 4 is the LCM here. Then you can get AC square plus BD square. But do the cross multiplication, therefore you can get 4AB square equals to AC square plus BD square. That means we have proved that sum of the squares of the sides of a rhombus is equals to the sum of the squares and the diagonals they have given. This is very, very important. Please practice once. Next, two poles of heights 6 meters and 11 meters stands on a plain ground. If the distance between the feet of the poles is 12 meters, find the distance between their tops. There are two poles they have given the heights. AB is one pole, CD is another vertical pole. They have given now with the heights of 6 meters and 11 meters. Poles means they are perpendicular to the ground only on a playground. If the distance between them, between the feet of these poles is 12 meters. Now, this is 12 meters they have given. Find the distance between their tops. A and C are the tops of these vertical poles. We have to find out the distance AC. Now, what have to do here? Yes. Now, in the figure, length of the poles they have given. AB is equals to 6 meters. CD is equals to 11 meters. Distance between these two poles, BD is equals to 12 meters. Then distance between the tops of the poles, AC is equals to question mark. AC we have to find out. For that small construction is needed. Draw, yes, from A draw a parallel into BD to meet CD at one point. Name this point as P. AP is drawn parallel to BD to meet CD at P. Therefore, these two are corresponding angles. It is a right angle, is also right angle now. You know very well that AB is perpendicular to BD, PD is perpendicular to BD. When these two are perpendicular, they are parallel. You know very well that. Similarly, from the construction, AP is drawn parallel to BD. When AB is parallel to CD, AB is parallel to BD. When two pairs of the opposites are parallel, it is a parallelogram. Parallelogram with a right angle is a rectangle. If it is a rectangle, opposite sides are equal. Therefore, yes, in the rectangle, yes, when, here no, just you can write, draw AP parallel to BD at A. Now we say that, now, what do you write now? A, B, DP is a rectangle. As I discussed now. What is a rectangle? All the angles are right angles. In a rectangle, opposite sides are equal. Therefore, AB is equals to, look at this now, AB is equals to PD. This, totally this is 11 meters. Therefore, when AB is 6 meters, PD also 6 meters, you will get it now. AB is equals to, PD is equals to 6 meters here now. Similarly, when BD is 12 meters, AP is also 12 meters. So, AP is equals to, BD is equals to 12 meters, I got it now. But, from the figure, CD is 11 meters, PD is 6 meters. Now, we have to find out the length of the CP. From figure, what do you write? From figure, CP can be written as CD minus PD. Look at this now. CD minus PD will give us CP. That means 11 minus 6 is equal to 5 meters. Now you have got, this is 5 meters, this is 12 meters. Here APC is a right angle triangle. We have to apply the Pythagoras theorem. So in the triangle APC, angle APC is equal to 90 degrees. By Pythagoras theorem, AC square on the hypotenuse is equal to the sum of the squares on the other two sides. So AP square plus PC square. AP is 12 meters. What is now 12 square? PC is 5 square. 12 square is 144. 5 square is 25. 144 plus 25 is nothing but 169. We want only AC. Therefore, AC is equal to root 169, which is equal to 13 meters. Look at from the figure. AC is the distance between the tops of the poles. We have got it as 13 meters. This is the way you have to do the sums now. Now one more sum. Just I'll explain. Try to do what you have to do now, please. In an equilateral triangle ABC, D is a point on BC. Yes, D is a point on BC. ABC is an equilateral triangle. D is a point on BC such that BD is equal to 1 by 3 BC. They have given very clearly. Prove that. What is your target here? 9 AD square is equal to 7 AB square. For that, what I have to do? Look at this now, very simple. D is a point on BC, they have given. ABC is an equilateral triangle. Therefore, how to write? You have got any idea? I will be taking equilateral triangle is A, this is A. Now look at this now, 1 by 3 into A by 3, we get this length BD. Now, whatever it may be, draw perpendicular from A to BC to meet at one point. Name this point as P, whatever it may be, join AD. When you know that perpendicular bisects the base, therefore BP is equal to A by 2 units. BD is half of BC, therefore A by 3. Calculate the length of the DP. You can get it now. Similarly, by using the concept of triangle ABP, calculate the length of the AP height will get now. Then apply the Pythagoras theorem in the triangle APD. Then you get the required answer here now. That is the way you have to do the sums here now. Remember, very simple here. BP is half of BC, therefore A by 2. BD is 1 by 3 BC, 1 by 3. Calculate DP. How do you calculate DP? Very simple. DP can be written as BP minus BD. BP minus BD. BP is, here I got it, A by 2. BD is A by 3. LCM is 6. Then 2 3s are 3A minus 2A is equals to A by 6. That's what I told you. Now, in the triangle APB, use the Pythagoras theorem. AB square is equals to, you can get what? AP square plus BP square. AB is equals to A square. AP you have to calculate AP square. BP is half of AC. Then you can get now A by 2 whole square. If I simplify this now, AP square is equals to A square minus A by 2 whole square. A square minus A square by 4. LCM if I take 4A square minus A square by 4, which is equals to 3A square by 4. You have got AP, you have got it. DP, you have got it. Apply the Pythagoras theorem, then you get the required answer 9AD square. Now, in the triangle ADP, what you do? AD square is equals to AP square plus DP square. AD as this, we can write now. What about the length of AP square? AP square is nothing but 3A square by 4. Then DP square, DP is A by 6. Therefore, A by 6 whole square. Simplify this now. 3A square by 4 plus A square by 36 Here 36 is the LCM. 4 9s are 9 3s are 27 a square plus